Hello, my name is Leonid Chigrinsky and my project is Robotont simulation, visualization and path planning. For navigation, I'm using Nav2 framework, and for localization, I'm using SLAM. Since I am not using Gazebo and everything is run inside the Docker container and exposed to the WebSocket for the Foxglove, there is no collision simulation. But even without that, robot is able to perform all required actions. The first step is that you can see you can use teleop keys to navigate the robot, and also you can see that it is successfully generates the map. Using Foxglove's built-in tools like publish to depose, you can set the target. Also, if you are interested, you can visualize the cost map that is using to calculate the obstacles and find the optimal path. And the planned path also is visualized using this widget called plan. As you can see, Robotont was successfully reached its goal. The next step that is required for this project was multiple points. For that, I did some workaround because Foxglove not allowed to publish multiple goal poses, but it have another tool, 2D point. You can put points like that, and I created separate node that converts these point data types into pose. Since points don't contain orientation, the orientation would be defaulted. And in order to execute these points, I created empty topic called exec. Sometimes it bugs out, so I need to clean them out. And let's try to put another few points here and execute. As you can see, robot starting to move. And it finally reached the final goal position. We can clear the points now. Also, another thing I implemented during this project is the map saving, because sometimes we want to debug some more complex shapes. For that, I can call it, let's say, maze complete, because we mapped out basically every obstacle that we have. We call this service. And it is successfully stored the files. Now let's talk a little bit about the files. Currently saved maps is stored under this corresponding folder. It is containing data for the visualization. And also we can load this map later using postgraph and .data. For example, if I run this command and call it maze complete, then rerun Docker again, it will be shown. And indeed, as you can see, map is loaded. Let's wait a little bit until we have everything set up. Yes, map is published, and we can use it again. As you can see, it generates bit artifacts. But it should be go away after restart. Also, the feature I also implemented, it is the map generation, because we are not using Gazebo. We need some way to create our own custom environment that is defined in the JSON file. And this tool is also stored in the repository. You can select different objects. You can put different objects. And if you want to store it, you just create new JSON file, name it accordingly, and in the environment, you just specify which world you want to use. In our case, it would be test. As we can see, it takes some time to boot up. So looks like we finished. And again, we have everything set, and we can use this custom map. Of course, everything else is working as expected. Robot successfully plans the path, avoids obstacles, and executes the goal. Thank you for your attention. I hope this was fun to watch.